So the last piece of the puzzle here on factory methods is to give you a peek under the hood at how factory methods are actually implemented. And this is kind of cool for a variety of different reasons, not the least of which it shows off the fact that reactive programming principles like message-driven are in fact embodied in the very implementation of completable futures in Java. So what happens here is when you call supplyAsync, it's going to arrange to run the supplier lambda, this thing here, in a thread that resides in the common fork join pool. So that's the starting point for this discussion. supplyAsync does not create a new thread. Typically, the thread pool will be created in a different way. Instead, what happens is a future is returned that ultimately will be completed by a worker thread that's running in the common fork join pool. So we as the caller get back this completable future, and we can do our own thing, and then at some point that future will be triggered when the computation finishes in the background. The parameter that's passed here is a supplier lambda that's going to multiply two big fractions together. Think very carefully about the late binding aspects of this code. This is defining some computation. It's a lambda. Remember, a lambda is essentially a nameless function or nameless method that can be created and passed around and then executed later, possibly in a different context. And that's exactly what's happening here. This computation will be run in a different context later. The different context being a pool of threads or a thread in a pool of threads. Although supplier get takes no parameters, we can use effectively final values to pass these parameters, these local variables, into the supplier lambda. We talked about that before. And the way that the worker thread that's running in the common fork join pool in the background is going to invoke this operation is by calling the get method on this supplier lambda. That will then trigger this computation to take place in a background thread. So that's the wonderful late binding behavior of lambda suppliers or supplier lambdas. Here's what things look like under the hood. If you were to peek behind the scenes here and look at the source code for CompletableFuture, which you can do if you click on this link, you will see that there's a method called supplyAsync. That's the method we're talking about. And here's how it works. It takes the supplier that's passed through. Remember, the supplier corresponds to this piece of code here. It takes that supplier, and it's going to basically do some magic to execute that supplier in the common fork join pool in the background. So this code here is how that happens. So here's the supplier. That's what it corresponds to. It's the supplier lambda that's passed here. Here's what we do. We take that supplier and we encapsulate it in something called Async Supply. We'll look at Async Supply in a second. Async Supply is a nested class in the CompletableFuture class. Remember, we talked about message passing. This is message passing right here. And then we're going to pass that new Async Supplier message into the common fork join pool. We're going to basically enqueue it for later computation in that common fork join pool. So this is a good example of message passing, which is one of those reactive programming principles we talked about. Here's what Async Supplier looks like. It's a class. It's a static final class nested inside of CompletableFuture. And you can see it extends something called async. And that allows it to be able to be used in a thread pool, in the common fork join pool in particular in this case. And what we do here is the constructor for Async Supply, which you recall takes this supplier. It takes that supplier parameter and it stashes it away in a local field in the instance of Async Supplier. So that field is then passed in there. And then at some point, and this is the part where you have to sort of suspend your disbelief for a second, the underlying common fork join pool is going to call the exec method back on the Async Supply object, which itself is an async object, and async implements or it defines the exec method. So in a background thread, a worker thread in the common fork join pool is then going to call the get method on this particular field, which corresponds to that lambda supplier, the supplier lambda we passed in way back when we called supplyAsync earlier. from the client code. So the thing that's a little confusing here is this code takes place in the calling thread, the one that was calling supplyAsync. This takes place in a background thread in the common fork join pool. This method, of course, is going to then, it could use the fork join pool manage blocker mechanism to auto scale the pool size for blocking operations. In this particular case, we're not blocking, so we're just multiplying two numbers together, so it's not a big thing. We don't have to use the manage blocker, but if you were to block, you could use the manage blocker here if you chose to, if you wanted your supplier to do that. So that's a quick tour through how the CompletableFuture factory method supplyAsync is implemented. And you can see what you're doing is you're creating a supplier Lambda in the client program, in the caller, in the main thread. You're calling supplyAsync. You're passing in that supplier Lambda. That supplier Lambda is then being encapsulated in something called an Async Supply object. And then that Async Supply object is queued for execution with the underlying common fork join pool. And when the underlying common fork join pools has a thread, it's a worker thread, has got nothing else to do, it'll pull this thing off of its queue and it'll go ahead and call its exec method, and then that will trigger a callback to the get method on the registered supplier Lambda, which will then go ahead and multiply the numbers together. And as you saw before, that'll take place in the background. And then it'll return a result. We don't really show that here, but it returns a result from that. And that result will then be used to trigger the corresponding CompletableFuture so that whoever's waiting for it ultimately can be notified, or whoever needs to be triggered next can be notified. Okay, so just kind of giving you a tour through this, and also just marvel at all the message passing that's taking place under the hood here too.